The denominator, that's going to be 1296 to the 5 over 4 times x to the 12 to the 5 over 4. Okay, can someone that was here on Friday let me know what to do to the 216? Go ahead.
You make it 6 to the cube, you know.
Yeah. Okay, now hold on a sec. That's correct. Hold on a sec. Can you please tell me why you chose 6 to the cube? Why do you want to be...
Because there's a 3 in the denominator of the exponent.
Good.
And you want, like, the 3's to cancel each other out.
Very good.
So, cube root or whatever.
Yeah.
You can get that.
Okay, Tristan, can you do the same thing with the denominator, please?
6 to the power 4.
Very good. Now, I mentioned this yesterday, very good, by the way. I mentioned this yesterday being Friday, that we want to have things cancel for us, okay? So, if you see a 6 in the numerator, chances are there'll also be a 6 in the denominator, unless I make a mistake, okay? So you can have things cancel. Okay, can I get a third volunteer to tell me, please, what 6 cubed to the 4 over 3 is equal to, please? Yes, Summer, go ahead. Good. And you're not done yet, Summer. What's x to the 9 to the 4 over 3 equal to, please? Yeah, which is, I'm just going to call it 12. Okay, because 9 times 4 is 36, and 36 over 3 is 12. Now, if that line is not clear, please raise your hand and ask, because this is fundamental to what we're doing today and tomorrow. So we're just using our power rules, but they're happening at fractions. That's the only difference, okay? We chose 6 cubed again because we wanted to get rid of the fraction. In life, we want to get rid of fractions when we can. I should probably my attendance, okay? Let me finish this example, that'll be my attendance. All right, can someone be brave and simplify the denominator? Go ahead.
Set a fifth,
Yeah.
x to the 15.
Okay, wonderful. Okay, 12 times 5 is 60, 60 divided by 4 is 15. All right, can someone be brave and give me the last 2 steps? So if you have three volunteers, Owen, go ahead.
So it would be 6 to the 1,
Okay.
and then x to -3.
Yeah, 6 to negative 1, no, x to negative 3, right? Okay, I don't like that as an answer. Let's close being done. Liam, finish it up.
Move those to 1.
Yeah, 6 to 1.
1 over.
Yeah, I'm just going to call it 1 over 6. X cubed, that works there. Okay. Okay, can I get everyone to close their eyes for a sec? Who has a fairly good understanding of what just happened? Raise your hand. Who does not have a fairly good understanding of what just happened? Okay. Yes.
Oh, okay. I was just wondering why it's 6 x cubed.
Okay, I'm going to pause the video and do my attendance before they call, and then we'll talk more about this.
No,
All right, here we go. This is number 8 from page 230.
Oh, wait, no.
It says the volume of a cube is 0.015625 centimeters cubed per meters cubed. Find the length of each side. Okay, now this takes a little bit of outside knowledge. What is the equation for the volume of a cube? You go ahead, Stella. It is length times width times height is a cube, okay? So if you think, I'll draw this as neatly as I can. Oh goodness, I can't believe I'm going here, okay? But here's my cube, okay?
Nice.
All right, so it is length times width times height will give you the volume of a shape like that. Now, if it's a cube, what do we know? Luke.
All the sides are equal.
All the sides are equal. So this is going to be like L, those are all the same. So I'm going to let L or set L equals, I'll just set any side. So length times width times height. What would length times width times height, Grace, stop please. What's length times width times height going to be instead? Only 2 people in the class know. Somebody please help, sorry, I'm picking on you. Anybody know? What's length times width times height if all the sides are the same? Sorry, Summer, I'm passing it. Go ahead. Length cubed, good. Sorry, Summer. L cubed is equal to 0.015625. And that's what we're going to do, cube root if we have to, okay? Okay, so we'll take 1 second here. So if you have the logic where that came from, right, if all the sides are the same, right, they're going to be L cubed or M cubed or X cubed, you can call it whatever you want. Now, you can either take the cubed root I'm gonna do it like this using exponents. What exponent would get rid of the cube? What exponent would? 1/3, excellent, okay. So I don't like the cube root in my calculator like this instead. Okay, can everyone, and please don't share the answer, do 0.015625 to the power 1/3 in the calculator right now? Okay, if you remember, if you were here on Friday, you'd be using like bracket 1/3, right, is what you'd be doing, okay, to make sure that it works out. This should hopefully be a nice number. I'm going to pick on Julia in about 15 seconds, once you give everyone a chance. Type in your calculator.
Why wouldn't we just use the cube root button?
Cube root button will work as well. I like fractional exponents, that's why. But cube root button will work. The problem is if it were to be like to the 8th,
Yeah.
the nth, if I don't want the nth root button, then you're like, how do you do that? And you calculate with the nth root, so
Yeah.
just a fraction. Go ahead. 0.25? Okay, was anyone unable to get 0.25? Please raise your hand. You were unable to. Unable.
Yeah.
Did you put brackets?
Maybe she moved one.
That's a 0.0.
All right, therefore, the length of each side is 0.25 meters. Is everybody okay, or? Oh, yeah. Good, okay. Therefore, the length of each side. All right, I'm going to move on to today's lesson if I can, which is called solving exponential equations. My last year's class got a kick out of this, but that's okay. Let's start properly though. Yay, math! Yay, math! Boo. Okay, solving exponential equation. Just as an aside, a kid in my first period class, I told the same joke to them, and they said they didn't know how to do the homework, so they Googled game math, whatever the lesson was, instead of watching my videos.
They watched the
game
game
math.
math.
Yeah. A little insulting, but that's okay. All right, solving exponential equations. Okay, this is a horribly important part. I know I say this a lot, but this is a horribly important part of this unit, today's lesson, okay? Is anyone here close to mention he was gone for hockey? Is anyone else gone for hockey next 2 days? No? Okay, good. You're gone for badminton on Friday? No.
There's people who wait for a CPR. Yeah.
Who's gone for CPR? Oh, shame on all. You're trying to do better yourself. That's ridiculous. Okay. We're going to say an exponential equation. For those people that are gone, if you come to see me, like you guys are in the school still, right? So if you,
Over at the church.
okay.
Yeah.
But if you come over like at 8 o'clock, or you can get a coffee.
Like I'll come here at 7.
Yeah.
In the morning.
I'm not here
And
at
I
7.
hope you do.
Oh, I'll be now with you.
I'll just sit outside your classroom.
An exponential equation is an equation with at least one variable in the exponent. I know you do. Okay, so my example is 2 to the x equals 16. All right, so this would be an exponential equation. This is the stuff we're dealing with a lot in this unit. Okay, if you came from 3M, this may look familiar to you. If it doesn't, that's okay. All right. It's called an exponential equation because the variables are up on the exponent. We're going to do today the opposite of what we did from Friday's lesson. Okay, so we're going to be converting numbers in and all that stuff like we did with the fractions. So we're going to say then, if we can get the basis to be the same, because the exponents will be the same. Oh, yes we can. Yes we can, actually. Yeah, I know.
That's like your famous joke, right? You didn't
It's not even a
understand
joke.
it. Yeah, you never understood why it was funny. It's still funny.
It's still not funny. I'm gonna say remove this time. So as we said here, if a to the x equals a to the y, then x equals y. And that sort of makes sense, right? If you have two things with the same basis, then the exponent should also be equal if the equations are equal, right? So what we're going to do in this questions are we're going to convert it so that the bases have to be the same. Then you set the exponents equal, then you solve for the exponents, right? So it's like sort of the opposite of what we did on Friday's lesson. Okay, example 1. So I'll give you a second to scribble down here so I don't need to get excited at it. Nothing now. All right, example 1, here we go. All right, 3 to the x equals 3 cubed. Okay, this one's like the level 1 difficulty question. Can someone tell me what x equals, please? 3, good, thank you. Okay, so we're going to say, since the bases are the same, we can drop the base. So therefore, just x equals 3. I've been telling that same thing for the last 10 years until this year wasn't funny, but that's okay. All right, that's fine. I gotta
We
live
should listen to Felix.
No.
No.
Here we go, example 2. We're going to say 2 to the 3x equals 64. Now this is where life gets a slight bit more complicated. Okay, but only a bit. You guys have great confidence in all of you. Can someone be brave and give me a suggestion, other than someone who was in my class last year, of what I should do at this point? What has to change, do you think? Oh, nobody knows. I'm going to get to 6 summer. Go ahead. Yeah, good. So we want 64. We want 64 to be 2 to the something, and those are question marks up there. Those are. Okay, Emily, I'm picking on you. With the power of your brain or your calculator, can you please tell me 2 to the what would be 64? This is where everyone should be getting the calculator. Doing it. If you do it, I think it's not. What number? 2 to the 6. Good. So 2 to the 3x equals 2 to the 6. And again, how you got that, there's probably a few different ways. We probably did like 2 squared, 2 cubed, 2 4, 2 5, 2 6, and so you got 64. Does that sound reasonable?
Is that an equal sign?
That's an equals. Okay, was anyone unable to get 2 to the 6 or know how we got 2 to the 6? We're all good, I hope? Okay, what did we do at this point? Thank you, drop the base. Okay, I'll remove the bases, I'll say this time. Drop. I just dropped the saying, drop the base, yes. So you have 3x equals 6. Last step, going all the way back to grade 8. Summer, go ahead. Divide by 3. So you get x equals 2. Okay, I'm gonna give you guys a minute to try one of these on your own right now. Are there any questions on what we're doing here? Right, the idea is to get the bases to be the same. Okay, that's the idea. The difficult part is going to be in a few examples when it's not easy to make the bases the same. Kylie, you're good?
And they're other fractions kind of being or at least one side going to end up being fractions since you're going to make it student.
Totally. I'm such a, I don't want to say jerk, I'm such a pleasant human being. Okay, I'm going to pause the video once I've done this one. So try example 3. Example 3 says 3 to the 3x plus 1 equals 81. Now this looks frightening again, but don't worry about the left-hand side. The left-hand side you can't deal with. The 81 is what you're going to deal with. Okay, I'm going to pause in the video. Stop, 14 minutes, no one's